Several recent applications of reinforcement learning, learning to play Atari games, control traffic signals, or even automatically configuring web systems, have been built on a single algorithm. This algorithm is called Q-learning. By the end of this video, you will be able to describe the Q-learning algorithm and explain the relationship between Q-learning and the Bellman optimality equations. Q-learning was developed in 1989 and is one of the first major online reinforcement learning algorithms. Let's take a look at the pseudocode. We've seen this format before. The agent chooses an action in a state, takes the action, and observes the next state and reward. Then the agent does an update, and the cycle repeats. With so many familiar elements, what's new about Q-learning? Well, the new element in Q-learning is the action value update. Here, the target is the reward, RT plus 1, plus gamma times the maximum action value in the following state. This differs from SARSA, which uses the value of the next state action pair in its target. Why does Q-learning use a max instead of the next state action pair? This connection goes way back to the dynamic programming material. If you look at the update equation for SARSA, it's suspiciously similar to the Bellman equation for action values. In fact, SARSA is a sample-based algorithm to solve the Bellman equation for action values. Q-learning also solves the Bellman equation using samples from the environment, but instead of using the standard Bellman equation, Q-learning uses the Bellman optimality equation for action values. The optimality equations enable Q-learning to directly learn Q star instead of switching between policy improvement and policy evaluation steps. Even though SARSA and Q-learning are both based on Bellman equations, they're based on very different Bellman equations. SARSA is a sample-based version of policy iteration, which uses Bellman equations for action values that each depend on a fixed policy. Q-learning is a sample-based version of value iteration, which iteratively applies the Bellman optimality equation. Applying the Bellman optimality equation strictly improves the value function, unless it is already optimal. So value iteration continually improves its value function estimate, which eventually converges to the optimal solution. For the same reason, Q-learning also converges to the optimal value function, as long as the agent continues to explore and samples all areas of the state action space. Let's review what we learned today. In this video, we introduced the Q-learning algorithm and described its connection to the Bellman optimality equations.